Okay, so for today's lesson, you are going to need these pages torn out of your workbook. Pages 249, and then the back is 250, 251, and then 253. I know that's a lot of pages, but these two you're just going to do along with me in the video, and the third page you're going to do on your own. I don't even think you're going to need to bring it to the Zoom. I think you can handle it completely on your own. And I would just like to play cards with you in the Zoom today if you want to come. So I'm going to go ahead and get started. First thing you're going to do is put your name on the top. We have worked with fact families before when we were doing addition. They were smaller numbers. These are going to be bigger numbers, but it's just the same thing. As long as you recognize that we're using a part whole mat, then piece of cake, right? So let's read the directions. It says, can you write 2 addition and 2 subtraction facts that use the numbers 8, 9, and 17? Since 17 is the biggest number, we know that's going to be in the whole spot. That's where the whole number goes. This is where the parts go. They made it big because it did say that you can use cubes to help you. So you might want to use cubes. So you would need to do 17 cubes total, and then you're going to put 9 in one spot and 8 in the other spot. I don't think we really need to do that. I mean, you could put 9 here and 8 there, but I don't see the point. Obviously, 9 and 8 put together make 17. You just need to make sure you know where they go in the equations. So if it's an addition problem, and this is important to pay attention to because you can't just put the numbers anywhere. Here you can see right away, especially if you highlight them, we've got 2 addition and equations and 2 subtraction. So the big number, I'm just going to put my 9 and my 8 here, is always going to go at the end of my addition equation. Okay, that's always going to go at the end. It looks like it's out of focus. Let me see. Try and make that better. A little bit better. Put it down a little bit. Kind of. So then these 2 numbers then are going to go as our add-ins, 9 and 8. And then we just switch them around, 8 and 9. Now, subtraction is a little trickier. You need to be careful because you're going to be taking away from the biggest number. So the 17 has to go first, you guys. Then you can put the other 2 numbers in any order you want to. It doesn't matter. And we've been doing a lot of subtraction. So you'd know that if you take 17, and then if you take away 9, you would get 8. And then 17, if you take away 8, you would get 9. So either way, you can swap those. Okay, let's look at the back. Now here she's talking about how to go about writing 2 addition facts for this model. So here we have the whole number at the top. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's the 9. And then here's the 6. And when you put them all together, they equal the 15. And you can add them in any order. It doesn't matter which order you add them in. That's why it doesn't matter which order you put the numbers, as long as it's the 15 comes at the end. You can also write 2 subtraction facts, but you always are going to start with the largest number. So 15, if I take away 6, is going to give me 9. But maybe I want to subtract the 9, and then I would get the 6. So again, it doesn't matter which order you want to go in. Okay, so these are the related facts. 9 plus 6 is 15. 6 plus 9 is 15. 15 minus 6 is 9. And 15 minus 9 is 6. You're taking the same 3 numbers and you're putting them in different places. The key numbers, though, that can't change in addition is the end number. You can't change that one around. And then in subtraction, you cannot change around that first number. It has to go first. If we look at the whole part, it's almost like a number bond, but it's a part whole model because here are the 2 parts and this is the whole. And they already did all the dotted numbers for you, so you could just trace right on top of those. And this time, look at, they try and trick us, and they do this with the equal sign. they put the equal sign and the number in the front instead of on the back. But it doesn't matter as long as you're paying attention. So 14 equals 6 plus 8. Those are the two parts. 14 equals 8 plus 6. Those are the two parts. Doesn't matter the order. Then we have our subtraction problem. Oh my goodness. I don't like that one at all. That's really confusing. And to be honest, I think what I want to do is do it this way. And maybe you might want to do this too. I'm going to cross this off, the equal sign and the number, and I'm going to put it over here because that is just way too confusing, especially with what we're doing right now. So I'm going to move my equal sign over to this side. 14 minus 6 equals 8, and 14 minus 8 equals 6. Okay, if that didn't confuse you, you don't have to cross it off, but that I think is weird to try and mess you guys up by doing that. Now here we have 16 is our whole number, and let's count how many on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 on that side. 1, 2, 3, 4, 5, 6, 7 on that side. All of them should equal 16 if you count them all up. So now we can make our addition problem or equation. 9 plus 7 equals 16. That's our whole. And then we can switch those numbers around. 7 plus 9 equals 16. Now I'm going to do my subtraction problem and put my big number first. 16 minus 7 equals 9. And 16 minus 9 equals 7. See how easy that is? You're really just taking the same three numbers and changing them around. You have to be a little bit careful about where you put them. But if you're thinking, you're not going to have a problem. Done with that page. I'm going to put that aside. So here we have some more part, whole models, and then some fact families to fill in. And what I'd like for you to do, which I think would be a really good idea, is just to pause the video and try and do it on your own, and then press play and then watch me fill them in and see if you did it right. So you can check and make sure you're understanding it. Okay, so now would be a good time to pause it and then go and try and do them on your own, and then come back and press play and see if you did them right. Okay, I have a name on this one. So 17 is my whole number, and my 9 and my 8. So 9 plus 8 equals 17, and now I just have to switch my numbers around. 8 plus 9 equals 17. Now I have subtraction, and sometimes this is good too, is just to highlight them so they stick out and then you don't get confused. Big number goes first in subtraction. 17 minus 9 equals 8, and 17 minus 8 equals 9. And you need to do that with all of these, and I think it'd just be a piece of cake. It should be easy. Okay, so then I have my 13, and 7 and 6 equals 13. So I'm going to do, here are those equal signs in the beginning again. I don't like those for subtraction. So let's do addition first. So for addition, I got to do my two parts here, 7 and 6, 6 and 7. And then for my subtraction, I don't know, you guys. I don't like it the way they do this. I'm going to do my addition first. So I'm going to have my 13 and my 13. Okay, now with subtraction, the big number is going to go first. So really, this is the first spot. But what I'm going to do is cross off those two, and I'm going to put my equal sign over here. I hope that didn't confuse you even more. I just don't like how they put that in the front like that. So I'm going to do 13 minus 6 equals 7. And then I can do 13 minus 7 equals 6. I just like to keep that number first in subtraction and not confusing you with the equal sign being in a different place. Okay, if you want to just do it without crossing it off, you can, or you can just cross it off like I did and put your equal sign at the end. Okay, this one is normal. I'm going to do this one. So I have 4 plus 8, my two parts, always going to go first and make my 12 for addition. And then I just switch them around. 8 and 4 equals 12. Now my subtraction problem, 12 has to go first because it is a subtraction problem. You don't want to get that confused. And now I can use the same two numbers, just put them in different places. 12 minus 8 equals 4. Now, sometimes they want you to think a little bit harder and they give you some other questions to think about here. It says, are the following equations a fact family? Explain your answer. So we have 9 plus 5 equals 14. We have 15 minus 5 equals 10. 4, I mean, 4 plus 4 equals 8, and 15 equals 6 plus 9. So they do have the same whole. This addition problem and this addition problem and this addition problem, they all are different. They don't go together. They don't have the same parts. So are these equations a fact family? No. They do not have the same parts. So you need to have the same parts and the same whole in order to create the fact family. And I'll give you a second to write that down. No, they don't have the same parts, so we cannot make a fact family out of those. Okay? Again, you can always pause the video if I'm going too fast. I'm going to do the back. So here it says, Pat arranged the counters below. Write the fact family for the set of counters. If you want to try and do it on your own and pause it, and then you can press play and see if you did it correct. I like the back. I think these are good ones. So I'm going to count all of my counters to see, well, I'm going to count my parts and my whole, and then I'll know how I can put them on here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 yellow counters. 1, 2, 3, 4, 5 red counters. So these are my two parts. So I know I'm going to have a part and a part. Now I need to figure out my whole. And they just put the equal sign on the other side again. And so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is going to be my whole. So 5 plus 9 equals 13. And then now I'm going to do 13 again. I'm just going to swap these two numbers. Don't let them fool you by putting the equal sign over here. But here they did it again for the subtraction one. And I'm sorry, but I am getting rid of that equal sign in the lines and I'm putting the equation over here. I'm going to finish it over here. Same numbers. You've got to use the same three numbers. So I'm going to have 13 minus 5 equals 9. And 13 minus 9 equals 5. Higher order thinking. That means that you really are going to have to think to do this one. Write an equation to solve the problem below. Then write 3 related facts to complete a fact family. So Tanya has 8 stickers. Miguel gave her 5 more. So there's our key word is more. And gave her. So this would be an addition problem because those are our key words. How many stickers does Tanya have in all? That's also going to be key to help us figure out that, oh, we're going to have to add. So we have part, 8 plus 5, and then we need to figure out our whole. So you learned so many addition strategies. You can use any of the manipulatives we have. You could use your fingers. You could use any the 10 frames to figure out 8 plus 5. And I think what I'm going to do is I think I'm going to count on. I'm going to start with my biggest number, and then I'm going to count on five more. So I'm going to start with 8, 9, 10, 11, 12, 13. So if I count it on, I don't need to have extra fingers. I only need the one added. So that means I have 13. So now I can do the rest of the part easy peasy because I just am going to change these numbers around to make my fact families. And then I'm going to make my subtraction family, same 3 numbers. I'm just moving them around and make sure I get them in the right place. So how many did she have in all? She had 13 stickers. Okay, this one is little robots. Write a fact family to match the picture of the yellow robots and green robots. So we got to count how many robots we have of each color. So we'll do the big ones first, and if you want to pause it and try this on your own before watching me, you can. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 red robots. 1, 2, 3, 4, 5, 6, 7, 8, 9 green robots. So those are our 2 parts. 8 and 9. Now I'm going to count all of my robots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Or I could have done doubles plus 1, right? 8 and 8, and then add 1 more because there's only 1 step between these. That could have been a really quick way to do it. I know 8 and 8 is 16, and then I just add 1 more, 17. Now I can turn these numbers, swap them around, keep the 17 at the end for the addition problem. And then I'm going to start with 17 here, switch them around for the subtraction problem. Pretty easy peasy as long as you understand that the whole numbers are where you can't switch them around, but the add-ins and the whole part. So oh my goodness, my mind. Your part whole. The parts are what you can move around. Wow, I got tired there at the end. I don't think I was making sense, but I think you understood what I was saying. So now the other page is the one that you do completely on your own. And I really don't think you need me for this. So here we have, and I really think you can do it. So we have these different part whole little formats here. And then on the back, we have another one and another one and then another one and another one. I think you guys can handle this one completely on your own. And then I'm still going to do my math Zoom at 12:45, but I would like to do card games. So if you want to bring your cards with you to the math Zoom at 12:45 and just do this on your own. I'm not going to do this because I don't think you need me to do it with you, but we are going to still have a math Zoom and play some cards, okay? So have fun, finish this on your own. I know you can do it, and then just send me a picture of your work when you're done. All right? Adios.